So in the upcoming session, we're going to talk a little bit about design principles when we have multiple tools at our disposal. So we heard about less in the previous session and what can happen when you have, lots of different tools and how you navigate that environment. As we're now adding more tools to the Cisco portfolio with Workflow, we have NSO with different constructs that we can use to design our services, but we also add Workflow to that. The question is, how do we properly partition our business logic? Which tool do we use for which task? But luckily we have Stefano Novello, who's going to talk to us a little bit about the design principles we need to keep in mind when we build our systems using both NSO and workflows. So Stefano is the technical solutions architect. The stage is yours, Stefano.
Great, thank you. So I just turn on my laptop again. Okay, so today I'll talk about intent-based orchestration with workflows and NSO. What I mean by that is combining workflows together with NSO, using NSO to represent intent and workflows to represent the fulfillment process. So my name is Stefano Novello. I'm a technical solutions architect. What that means is I work in pre-sales, I do proof of concepts, I do demos, I come up with architectures, all to do with automation, and I've had a number of proof of concepts where we've combined NSO with workflow tools. It often happens, right, that there's an existing automation environment, and NSO has to sit underneath and be driven by that, and that adds constraints, and so that's where my experience comes from primarily. Oh, yes. So my talk is in two parts. The first part is really about what it looks like when you combine workflows with NSO, and the second part is about design principles. So what is a workflow? From the Oxford English Dictionary, it's a sequence of industrial, administrative, other processes through which a piece of work passes from initiation to completion. So I think it's important is the fact that we have processes in there, we're representing a flow of work, and it's end-to-end. In IT, we tend to represent workflows using workflow definition languages. They often look like this with graphs. The graphs have nodes, which have different kinds of nodes. So there are start, end, activities, choice, events, messages, all sorts of different things that have to be done in sequence, essentially. And we have the edges, which represent the preconditions. It's not the only way to represent workflows, but I think it's a very, very common way, this one. You can have, of course, then you have the instances of the workflow, of course, so which are running through, which are in progress, and we represent the instances by what activities have completed, and we have data that is being passed from one activity to the next, or from an event to an activity. That data is also stored there. We have the logs. And we have the engine which runs the workflow, so which executes it, persists it, logs its execution, just to have that. NSO, I'm not going to read the definition of this comes from Cisco.com. It's, well, we can see that we don't have the precision of language of the Oxford English Dictionary, but it's a bridge between intent and action. I think that's the important part of this definition. If we look, I think many have seen, I think all have seen this kind of slide and the main features of NSO. I'll go through, how the different features work when we have NSO under a workflow. So the first is that NSO is model-driven. It means that we'll define the models, that will define its API, and only because we define the models, we'll ensure that only the parameters that we really care about in the workflow needs to be exposed to the workflow, and that's going to be a big benefit. It's also multi-vendor and multi-domain. So if I build my integration between my workflow system and NSO, I'll be able to manage a whole raft of equipment in one go. And I don't have to redo the integrations for different types of equipment. It abstracts intent. What I mean by that is the service abstraction and the fact that we have FastMap. So the fact that I can have a CRUD model to affect a high-level service. Of course, that's going to simplify things for me, right? And the final thing is it's transactional. So I just mentioned before about the state of the workflow. Usually it's stored as these are, the activities that have completed. And this is the set of activities completed, and this is the data pass between the activities. That means that the workflow really assumes that an activity is either started or is completed, right? It's like an atomic thing, and it shouldn't be that it half completed and did things halfway. So we need that all or nothing expectation when a workflow calls an underlying system. And so the transactionality really helps us there. So I thought I would then have a section about what are the advantages of NSO plus a workflow. And I have to, if you're going to have advantages, you must compare against something. And so I structured this in two parts. The first is like, what are the advantages of having a workflow over a web UI, which is stateless? So this could be the web UI of NSO, or it could be a custom-built web UI. But the important thing that I want to compare against is if it's stateless, in the sense that it only has state within the browser of the specific user, right? So the first thing is that I will model the order process. So I have the log of the workflow. I know all the changes that have gone through NSO and where they're at and what's in progress. And this isn't built into NSO. I can look into the transaction log and so on. But if I have complex changes, which might be multi-step and so on, it's actually very hard to go into NSO and see, what are all the what orders have flowed through the system. I have a different model of working. So the workflow can typically prompt the user. I, as a user, can come in and say, what are the outstanding workflows that are waiting on new inputs and so on, and maybe I can provide them. And that way of working is, again, it's hard to do if you just have NSO, which tends to be static until you go and you make a change. So it's driving. It can remind users of things that are changing. It's natural to do checks and approvals in a workflow engine. So one thing is, a very simple thing is, I want a second person to look at a deletion. So I set up a deletion, and I need a second person to check that that deletion is okay. If I have a stateless web UI, that deletion exists only in that web UI, and it's kind of hard to then pass it to somebody else and force somebody else to look at it if there's no workflow. Similarly, if I have to provide the user with a set of information and they have to take a decision, that's also not natural if I don't have a workflow. So those kind of checks, not automated checks, which NSO can do. So if NSO is doing a short ping or whatever, and it has to check that it works, that's something that it can do itself. But if I have to present the user and the user has to look at all sorts of information, that can be done in a workflow better. I can represent long-running processes. So, of course, I have in NSO, I have tools such as nanoservices, for example, to represent a process with steps. But what if I have well, recently I was with a customer who told me that they, when they turn on an optical link, they will run tests on it, or they'll just keep it running for 2 days before they hand it over to the IP engineers who will then provision the IP link on that. And the reason is because they found that they need that long to get proper bit error rate statistics, and they find that sometimes the link is unstable in the first couple of days. They can catch many errors that way, so they have that process. So I could represent that in a nano service, which was incomplete. But I think it's better to represent it in a workflow, because I might be able to interact with it in a way that it's hard to do with a nano service. For example, I might one day be running my bit error rate test, and I see the bit error rate is not okay. I could see that early, and maybe I want to interrupt and go back and not waste 2 days. I might another aspect is that if I have my intent in NSO, and my intent is saying that everything is configured, and it's just waiting for that bit error test, and it's nice that I just have the intent that we are before the test. And the final thing is east-west integrations. So just if I have systems and they're having east-west integrations, and I have many systems in my environment, I could end up with many integrations. And people sometimes prefer to have an overarching system that is integrated with all these systems, and then keep reusing those integrations, and always have the overarching system talking down. It's just a way of simplifying my environment and having less places to worry about integrations. And that, for example, Cisco IT, they use ServiceNow to represent workflows, and they use it right across. And it might make sense for them to allocate an IP address in ServiceNow, talk to an IPAM system, and then tell NSO, because in essence, they've integrated their ServiceNow with that IPAM system already, because they've done other projects, and they reuse that integration when they talk to NSO, for example. The next slide is about the comparison of a workflow engine, of a workflow plus NSO to a workflow with a template engine. So again, here we're stateless under the workflow engine. So that before it was, I have NSO and I have a stateless user interface, and now I'm stateless in the interface to the network. And the first big advantage is federation. So I have a place to represent my intent, and it's separate from the workflow. If I have a stateless system under my workflow engine, then somehow my intent well, I can't really store my intent in a workflow because the workflow represents an order, it's a change. So if I have a service, there will be many workflows referring to that service over time. The creation, every modification, its deletion, and all of these have to somehow know the state of the service. So I probably need some extra database, and basically having NSO there gives a direct place to know the intent of the network is stored elsewhere. Compliance reporting. If I have a template engine system that's driving my changes, it's stateless, so it doesn't know about the services and what happened in the network. I won't be able to do. I won't be able to handle a change that was created by a user directly on a device and seeing, okay, I'm no longer compliant. My service is out of sync. I have to push it out again. So all those NSO advantages are not there for you. It's possible to have fewer, more generic workflows. Clearly, if I have NSO underneath, I could create a workflow, a generic workflow that maybe edits any parameter of a service. I just load in the whole service, let the user change anything in the service definition, and then output it again. And I know that underneath I have a system that will push out that. So I don't need to have a different workflow to edit one part or another part. I know exactly that all workflows, all changes will achieve that. And there's a more specific slide later in the design section about this. The workflows become more simple and more understandable. That's just because of the service abstraction. So I have a higher level way of talking to the whole network. With a single call, I can make my change. That's going to lead to better documentation and better sharing of my workflows so that people understand what they are. And I'll have less exception handling and complex fallouts. And that comes from the transactionality, from the ability of NSO to give me an all or nothing change. Now, clearly it's possible that I have drawbacks from having these two systems, as it is more complexity. And oh, by the way, this calf, I came across it in Bologna, and it's 500 years old. It's stuffed, and I thought a two-headed monster was a good representation of the pitfalls of putting two systems together. You don't want a two-headed monster. And if I just try and be more concrete, say I have this workflow and it's failed, and I'm trying to troubleshoot. What do I do if it's reached a certain point, and there are plans inside of NSO that are half complete as well? Am I really? How good is my integration between NSO and the nano services to really understand what point I'm at and where the errors happened? I have to look into two systems. One issue that people come across is agility. So what if my workflow engine says I can only work with exactly this version of NSO? Then and I need to update to newer versions, or I need to update my workflow engine, and I might lose agility. So I have to take care of that when choosing which workflow engine to use. There's of course a learning curve. All technologies have learning curves. So when I'm learning my workflow engine, do I have to learn all sorts of proprietary things that are in that workflow engine, or I've put in a lot of effort already into learning NSO. Do I have to learn all sorts of other strange technologies that I'm not going to reuse anywhere else outside of that workflow engine? So that's also something to take care of. Okay. So that concludes the overview of combining workflows and NSO. And let's move on to the design of workflows that have NSO under them. You can ask live questions. I'm happy if I haven't said that before, but go ahead. So when designing a workflow, it's my belief that you should always start from the operator. So there are two big hurdles that I've seen in automation projects. The first big hurdle is getting your automation live in the network. And when people develop automation and it stops and doesn't get live, the reason is that they haven't involved the operators really seriously right from the beginning. So understanding the operational aspects, and that includes InfoSec, just referring back to Mark's previous presentation, right? You want to really understand how your automation is going to work and be accepted by the operators. The second big hurdle is you've got the first version out of your service, and then you see that it's very hard to change. And that is just about having solid testing pipelines, CI/CD, making sure that you are able to actually evolve and release new versions of your service. So I see those are the two big hurdles, but the first one that I want to talk about is this making sure you get information from the operator. And you want to ask them about simple things like what steps do you go through, what are the decisions you take, what data do you think you have to enter, and where does it come from, how do you know that, and what are the typical errors that you expect to happen and you want to avoid during the execution of that workflow. So if I take an example, and I'll be talking about this example later or referring to it. Say I have a service, and I ask the operator, what do you mean by this IP link service that you want me to automate? So the first thing might be it should be end-to-end. It should be from the cabling all the way up to being able to put this into the IGP. And I have issues today in finding which ports to use, which are the free ports, and so on. And I would need help there. And sometimes I have to stop and cable something or get an SFP, and that takes time. When I have the link up, I need to look at it and understand the optical power levels, bit error rates, etc., to turn it on. So I can't give you here's a pattern that will make it that I can say it's fine. I need to, based on the geography and how long, I don't know how long the fiber is and so on, I will have my idea about what's acceptable and what's not. So then it could be a lag or a simple link. That's just a property of something, different kind of links they want. And they also need to onboard it into their assurance system. So being able to talk about workflows, I think, is a great way of eliciting information from the operators, because they're often thinking in terms of those workflows. And I believe also, if you come to the operator and say, talk about service extractions and which will be your services and so on, you do get the sometimes blank stares. It's very hard to look at a network declaratively when you're all the time looking at the flows of change that are going on in that network. So it's also a nice way to learn in detail about what the issues are and what's hard for the operator. So where do you represent the intent of that workflow? Well, you certainly don't do it in the workflow. You want to have at least possible in the workflow of what intent you have. And you want to have the same abstraction level as the operator is using when talking to you about the service. So exactly all those parameters that the operator finds matter to them, you want to expose in your workflow. You can use, so not only do you have the service abstraction in NSO, but you also can define actions, you can define queries. So, it's important to use those because you have all those situations in workflow where the user has to be presented with a bunch of information and they have to take a decision. And having an NSO action that goes and gathers up all the information to support those UIs where they will take those decisions, that makes a lot of sense to use actions to abstract how you're going to get that from the network. So again, the workflow doesn't have to be exposed to whatever processes you have to go through to collect all the information to take a decision. Then there's the question of where do I allocate resources? So the big question is there are two questions there. The first is like, where do I store the resource that's been allocated? So do I use an external system like some inventory or IP address management, or do I store it in NSO? And then there's a secondary question like who is it that makes the request? Is it NSO with an east-west type of relationship, or is it the workflow that requests the resource and then passes it to NSO? So I think the important question here is really where I store. And where I store is to do with visibility and with how many systems require that resource. So IP addresses, of course, are typical, where I have a large IP address pool, but they have to be all unique, and many systems will want to allocate from that same pool. And there are other resources like a VLAN or whatever that's local to a link. I would want to hide that, of course, inside NSO. And so I think that's the answer to the question. Use NSO as much as possible for everything that can be hidden. And you can use external systems, and the reason to allocate from outside of NSO is for reuse of my integration to the inventory system. So if I've standardized on a workflow engine for many processes and many tools, then I will already have those integrations, and it may be good to put that into the workflow engine, as opposed to an east-west direct integration. One of the issues that can happen when I have workflows is that I have what's called a workflow explosion. So I have like loads and loads of workflows. And where do they come from? So one is like, I'll need a workflow, at least one per service type, but actually I'll have different operations. So for every service type and every operation, I'm going to have a workflow. A workflow tends to be long-lasting. So I'll probably have multiple versions in use at the same time. So when I switch over, I'll have workflows that are still running on the old version and running now on the new version. And I think it's common that we have workflow engine tools where we want to express a workflow, and then we find that we need small variations, and then we go and change the workflow. An example, I create a workflow to upgrade some device from version 5 to version 6 of an operating system, and then I try that same workflow to upgrade from 6 to 7, and I think I just have to change those 2 parameters, and no, 6 to 7 have more memory requirement, and I run out of memory, and I can't run this, and then I have to change the workflow, right? And so I create a variant of that workflow for upgrading from 6 to 7, right? So, and often it's to do with also these graphical languages. They make it hard for me to write something like a procedure that I can refactor my code and so on. I tend to copy the whole graph and then change it. And that's the reality. I see that in many workflow engines, that actually that's the way people end up doing, and that's why they have these explosions. And of course, NSO helps me along most of these axes. So the fact that NSO is model-driven means that I could actually have workflows, a common workflow that might work across multiple services. So if I have the ability, for example, to have some, in my workflow, look into a map that says, here's the form for this service type, maybe the creation could be actually the same workflow for multiple services. Why do I have to make a different workflow for different services? I just have to make a new form, right? If the creation of that service is basic, right? Maybe I can, find ways of abstracting and, doing special things in special sub-workflows and so on. So I can, because I'm model-driven, I have ways of limiting the number of workflows and structuring them in a way that is consistent across services. Similarly, operations. I have these CRUD interfaces that enable me to have less workflows. I've already talked about the modify operation, but also if I think of all the different operations that NSO offers on a service, such as undeploying, redeploying, etc. All these kind of different operations, they could also be a parameter, right? I don't have to go and offer special workflows for different operations. Versions and variants, well, a lot of the time, all these little distinctions that I'm making in my workflows are to do with the fact that the workflow has a very low-level interaction with my network. So and this is why I'm arguing for the highest possible level of service abstraction between NSO and the workflow. If you have that high level of abstraction, maybe the variants and the versions could be handled at the NSO level, right? And for the versions, for example, there's the version flag pattern, I would say. You add a flag into the service to say this is version 1 or version 2, and then you can control the migration from the previous template to the new template. And so it just looks to the workflow like the service has an extra flag, right? And then you can control that migration carefully. So this is 3 minutes. So this is the last slide, and it's about synchronization. So what I argue for is to keep things as simple as possible. But there are triggers that cause you to move to more complex patterns. So what I really want to do is just make use of NSO transactions, use NSO synchronously, and just let it finish. That would be the ideal. And it leads to the simplest and most robust ways of creating workflows. But of course, sometimes I need a higher throughput, and the answer is commit queues. So I would say the best way to use commit queues from workflow is to use the synchronous flag. So I return when the commit queue is done. So I know the workflow proceeds when the device has actually made the change, and roll back on failure, which means that I get that all or nothing behavior. So what am I losing? What am I losing? I'm losing isolation. So when I use commit queues, the new intent appears in the database before it's actually on the devices. And so if I have a service that reads from those areas of the database, such as reads from the configurations created by the service, or reads the other service to find some parameter, then they have that other service, if we're not careful, could take the wrong decision because it's assuming that intent is already there. So we have to take that care of, we have to just be aware that we've lost that isolation, but I think that's a small price to pay for, of course, being able to address all sorts of more use cases which require that higher throughput. I could have phases with short steps. What does that mean? So I configure things, and those configurations don't really last very long. So what I think is a great next step is to have a service with a step variable. So I have, I'll give an example. Configuring of a virtual interface. So I configure 2 interfaces and a virtual interface for redundancy. If I do that all in one go, I do those in parallel in NSO. Both appear at the same time. They don't see each other because they haven't turned up. And you have an immediate split brain scenario. Seen that happen. So what you want to do is you want to configure almost everything, just not the backup interface. Then ping the virtual address. When I have the virtual address pingable, then I configure the backup virtual address. And then I'll immediately be with active true. I'm over time. Okay. So very briefly, what I want to say is if I have short steps, then a good way is a step variable. And the final thing, sometimes I have long automated steps. That's a trigger for using nanoservices. So long automated steps means I have a long step, but I'm doing something in the automation system, not a long step where I'm waiting for cabling. It's a long step, for example, I'm booting a VM, right? And in those cases, I cannot stick with these step variables. I have to really go and let a system like NSO actually have a nano service, and that means more complex integration, because when I start that nano service, I'm going to have to monitor when it ends and get an event back and so on. I'll need that more complex integration, but I only want to use it if I have that trigger. I have those long automated steps. And otherwise, why go there? Right. And that is the conclusion. I'm a little bit over time, but are there questions?
I'm afraid that we're running a few minutes late, Stefano.
Yeah.
We do have questions on Slido.
Okay.
And I have to apologize to the people who asked them that we cannot take the time to answer now.
Oh.
But please look up Stefano afterwards and ask any questions you want. There's going to be time for that later on. So thank you very much, Stefano. Great session.
Thank you.